Topic 7-1, exponential functions. This can be referenced in our Holt textbook, Chapter 11, Section 2, starting on page 772. All right, when dealing with exponential functions, you're going to want your graphing calculator because it's actually going to show you how each of these work when you're asked to put in a certain domain values and find the range values. Just using some terms, just remember that your x value is your domain and your y values are your range. Okay, these first four problems only need to be put into a calculator, but to take anything to a higher power than 2, which is normally using this button right here, is to use this house top. So 4 raised to the 1.7, just round to the nearest hundredth for these expressions. So this would be 10.56. So I won't do each one of them, although let's look at number 3. You would want to put this in parentheses because it's 2 divided by the 3, that entire expression raised to the negative 1.2. So be careful that you put it exactly like you see it in your problem. Okay, look at y equals 4 to the x. Go to your y equal button and put in 4 raised to the power of x. So use this little symbol here when you're trying to put an exponent. So let's look at the graph of this. You're actually never reaching 0, so your graph will really never touch the x-axis. But you do want a couple of points. 2 or 3 is best, although when you go to your table to get your points, let's look at our positive numbers, or starting with 0. At 0, you're at 1. At 1, you're at 4. And then 2 jumps all the way to 16. So you're kind of off of the coordinate plane graph. But with 3 points, you have enough to draw a nice curve. So try to get at least 3 points. But this line approaches this, but never actually touches it. You can see that if you go to each of these, it continues to get close and close to 0, but this has gone to scientific notation and where it will never touch the x-axis. Okay, if you've got the same equation, but all you do is add a negative 8 to it, so you're saying y equals 4 to the power of x minus 8, the graph is different from the one in the first one, is that it's shifted down. So notice it's the exact same shape of the graph, it just shifts down. So you'll want to look at the points that they gave you here and go ahead and fill them in here too. Second table gets you to your points. So you're going to go slide down to negative 2, round it to the nearest hundredth place, and put in each of these points, and then graph some of the ones that are whole numbers. It'll be easier. You've got a 0 and you're down at negative 7. 1, you're down at negative 4, and 2, you're up to 8. So your 3 points actually are all inside of the coordinate plane and easier to draw. So make sure you answer the bottom question, how does this differ from number 5? And the only thing that happened by subtracting is that it shifted down 8 units. Okay, look at number 7. On this one, they're asking you how is it different from the one in number 5. And remember, if you want to write up here, the one in number 5 was y equals, number 5, was y equals 4 to the power of x. So on this one, if you change the power of x, so you can use this one but delete what's there, and say 4 to the x minus 1. Graph it. Oops, graph it. Maybe I didn't put that. I think this is good to note here. You have to put this in parentheses. Otherwise, it's going 4 to the x and then a minus 1. I know that because it's shifted down below, and that's actually wrong. So you do have to put in a parenthesis. So be real careful. make sure to put your parentheses around the raised to the power. So make sure it looks like that. So then when you go to your table, you're looking at values when it's -2. So rounding to the nearest hundredth would be 0.02. Fill in your values, and let's do the whole points. 0, it's at 0.25, so it's kind of right here in the middle. 1 is at 1. And if you walk over 2, you go up 4. 1, 2, 3, 4. Again, if you get 3 points, you can make the best curve that you can. So what happened on this one compared to that one is that it shifts to the right. So remember, when these are positive numbers along your x-axis, and from here to here is negative numbers. It's actually doing the opposite move. If this is to a negative, you're actually shifting toward your positive 1 unit. So it shifts right 1 unit. The opposite is going to be true with this one. Put that one in your calculator as raised to the power of parentheses x plus 2. So all you got to really do is change this to a plus 2. Go and get the points with 4, 3, 2, negative, all these negatives, and then draw your graph. And off of the coordinate plane with 0, 19. So look what happened to this one. Not only, I'm sorry, it has a plus 3. So you're going to come over here and on the outside of the parentheses say plus 3. There's your points. So now we got some nice whole numbers. So use these whole numbers for your 3 points to plot on your graph to be able to draw it. So not only did it shift to the left this time, showing a positive 2, so it shifts left 2, but it also moved up 3. This movement right here shows the up movement. This movement right here shows the movement to the left. All right, the only change in number 9 is from number 5 is that this is upside down. So the only difference is it reflects across the x-axis. Where the first one was up, these are going to be all opposite values going down. So with the reflection, make sure you put a -4. Let's just make sure we do that. So you would say -4 raised to the power of x. That's your graph points. Right, we got these right. Yep, that's right. 0, -1, 1, 4. Oops, that's 1, -4. And then 2, -16. So there's graphing exponential functions.